In the following exercise, we're going to go through some basic types of JavaScript and its power to type check using the prior examples that we set up. This example has nothing to do with React. This example is about Hello World written in TypeScript. And then we use TypeScript compiler, TSC, to compile TS file into a JavaScript file. And then we use Node to run the JavaScript file in the console. Before we start, let's look at some of the syntax highlighting and semantic highlighting that is available through Visual Studio Code and TypeScript. If you already have your TypeScript installed, you can use the syntax highlighting to see about these things. In that Hello World example, we roll up the message and console log it in TypeScript. And then we use TSC Hello World to compile that TypeScript, and a hello world.javascript is generated. We switch over to hello world.javascript, and we notice that there is a difference in the declaration of message. Whereas in hello world, we use the block level scope let, but in hello world.javascript, we see var. This is because in tsconfig, we specify that the compiler by default transpiles to pre-ES6, in this case, ES3. The let keyword doesn't exist in ES3, so the emitter must emit the code using syntax available in ES3 var. If you want your TypeScript compiler to emit with the let keyword, then you must target ES6. Inside your tsconfig.json, you will then specify target as ES6. Doing so will output with the same code that you input. Let's go to our TypeScript and create an object. This object has both width and height, and close it. And then let's declare an area, which is object width times object height. Now, in this case, we're going to purposely misspell height by adding a whole bunch of stuff to it. And let's see what happens. We'll save this file, and let's tsc hello world and try to compile it. Notice that we're getting this property height, whatever, does not exist on type with number and height number. You can see that this is part of the IntelliSense. In your JavaScript, you're not going to see this type of error, but when compiled, your TypeScript is going to catch this error or misspelling to prevent you from bringing this error into JavaScript. Now, let's copy these 2 lines of code into JavaScript. We're going to save this file. This time, we're going to use Node to run hello world.javascript. And notice that it runs. What does that tell you? Well, this means that JavaScript does not care whether you have misspelled a property name or not. JavaScript proceeds to interpret your code as it is by outputting the hello world to the console, bypassing this error completely. As you can imagine, in production, there could be possibly misspellings here and there in thousands of lines of code, but a lot of these issues went undercovered. And developers simply don't know about it, because if there's nothing wrong in production, you're not going to get any feedback at runtime from your code. And this is pretty bad. This is one of the reasons why we use TypeScript to govern the type checking of your code before it runs. And let's switch back to hello world.typescript and mouse over this. As you can see here, this is what we call syntax highlighting in TypeScript. Width being a number, height being a number. This is part of the IntelliSense library in Visual Studio Code. You are getting syntax-rich feedback as you write code. So this is a very useful feature powered by TypeScript that gives you predetermined syntax issues so you can resolve them before compilation. Let's go through another example here inside JavaScript. Let's say we create a variable integer, assign a value of 10, and later on, for the sake of illustration, we're going to assign a string to it, save, and see if we can run this. We're going to use node.js. Again, there's nothing wrong with this. In fact, we can also console log type of amount and see if this actually gives us something. Node.js, hello world.js. And now, as you can see, amount is of type string, even though it was declared as an integer. This illustrates one fact. In loosely typed languages such as JavaScript, You don't have to specify any types of variables. JavaScript is a very, very loosely typed. This type of flexibility could introduce a lot of issues down the road or even bugs. For the sake of an illustration, we're going to copy this code, type the TypeScript, save. Even before we compile this, let's mouse over and see what happens. Now you can see TypeScript gives you the context behind what it is you're doing. That way you can see the problem just in time and apply quick fixes when possible. JavaScript does not have the capability to declare that a variable is of a particular type. This means that the type is inferred from the value it is assigned. There is no strict type checking in JavaScript, which means that a variable could be changed to hold any value at any given time. The lack of a rich type checking system with a type checking process is what TypeScript brings to the value. We'll learn how to use this type checking system in this session to make us more productive when developing React applications.